Um, Welcome. Thank you for joining our webinar, Deep Dive, What's Next for EigenLayer Post-Launch. My name is Ben. I'm a protocol specialist at Figment, covering the Ethereum ecosystem. I've got to say, I think EigenLayer and restaking on Ethereum is one of the more exciting things I've seen since the launch of Beacon Chain. So very excited to be joined by Sreeram Kannan, founder and CEO of EigenLayer. Sreeram, if you wouldn't mind giving a brief intro.
Yeah, thank you so much, Ben. Really excited to be here. I'm Sreeram. I started the EigenLayer project now, coming up on 3 years. Before that, I was a professor at the University of Washington, Seattle, where I ran the AW Blockchain Research Lab. Um, EigenLayer is a mechanism allowing for the trust network underneath Ethereum to serve other systems. The reason we started it was as an academic, we came up with a lot of new protocols which required base layer changes. And if you had ideas that you want to experiment on base layer level changes, then you had to go build a new base layer yourself, like a Alt L1 or an Ethereum killer. And that just seemed like a waste of energy for each new idea to create a new ecosystem. People who have these ideas are usually very technical and like they focus on some narrow range of the stack. That's when they're really good at it. But the requirement to go build a whole new layer one is like a massive endeavor. So EigenLayer was designed to solve our own problem, which is that, hey, we have ideas, we can't like test it in prod anywhere. And, can we actually create a system for it? So that's a brief.
So sorry, just so I make sure I'm clear on that. So you were interested in changes to the base layer and things you wanted to accomplish, and EigenLayer was the necessary piece for that, basically. Okay, fantastic.
Yeah, but of course we can't change the base layer, but something at the level of the base layer, because you can run a new consensus protocol and test it and see how it works. You can run a new data scaling system. You can run a new data storage. All of these kinds of things. You have ideas, and we used to even have implementations in our own lab, but also other academics I used to see have like really cool new ideas, and the only thing that you could do was to go build a new layer one. And we do see that, for example, from the Facebook Libra team, which was a very academic team, Sui and Aptos spun out and then come out. But those ideas were there 3 years before. You didn't need a Sui and Aptos to be born to actually manifest some of those ideas. And that's the kind of attempt of EigenLayer.
Very cool. Very cool. Let's go get the next slide, please. So kind of before we dive into all these topics, I do have a slide deck for folks that are watching. But really my hope is to keep this conversational. So just meant to be mostly a conversation. For me, the slide deck helps just to kind of keep things organized and kind of some loose sticking to broad topics. So really what I'm hoping to cover today with you, Sreeram, is three basic things. Kind of a restaking 101. So for folks that are a little newer and just kind of getting into the space, I want to talk about what is restaking, what is EigenLayer, which you already kind of talked about. Maybe we can dive in a little bit more. And then why is restaking, in addition to the points you've already made, why is restaking, why is EigenLayer so important? I think there are a few kind of big points to be made there. And then the last thing is just looking forward. What can we expect over the next 12 months and beyond? And by the way, for folks, for participants, if you have any questions throughout the presentation, please feel free to add them in the Q&A section. And then we can hopefully field them as they come up. Next slide, please. So maybe it's helpful just to get started, taking a bit of a step back from EigenLayer and just talking generally about restaking. And I think, for most folks participating, this will be, you already know this, but I think big picture, the idea with restaking is you're securing multiple protocols with the same stake. So, if you've heard of things like replicated security, shared security on some other networks, it's not necessarily the same thing as what we're talking about, but it's very similar. It's a similar concept. So, obviously, from a staker's point of view, it's very interesting because, of course, you have the opportunity to earn additional reward streams. But I think, as we'll probably get into, the benefits are much broader than that and much more important than that, let's say, in terms of the aggregate that restaking brings. As you already mentioned, Sreeram, the ability to kind of bootstrap new protocols, you don't have to go out and create a competing base layer. You can tap into to folks that are already staking, already engaged in the behavior that you want for your protocol, and you don't have to recreate that. You can essentially tap into that pool. And for folks on the call, the slide here is just a sampling of some of the so-called actively validated services or AVSs that are being built on EigenLayer. We'll have more to say on that in a bit. But when you hear AVS, if you're kind of new to restaking in EigenLayer, when I say AVSs are actively validated services, just think of protocols built within the EigenLayer ecosystem. Next slide, please. So Sreeram, I know you already kind of talked a little bit about EigenLayer, but if you wouldn't mind just giving a little bit more here in terms of restaking and what exactly EigenLayer is.
Yeah, absolutely. When we say restaking, what do we mean by that? The source of trust. So abstracting it out, essentially, the main thing that differentiates crypto, this whole area, from, like, let's say, cloud, right, is decentralized trust, right? And what is, the source of decentralized trust? Let's take Ethereum. The source of decentralized trust is really that there is an amount of stake that has been put in, and stakers are promising that if I'm going to run the Ethereum software correctly, and if I don't run it, I'm liable to lose my stake. This is called flashing. And this is what underwrites the trust of Ethereum itself. Like, why do we trust Ethereum is going to run correctly? It's because of this. If that's the case, then how can we expand that? If decentralized trust is the raw material out of which the crypto economy is created, right? One way that people have articulated this before is that block space is the material out of which the crypto economy is manifested. But block space is just distilled decentralized trust. It's, there's a stake and operators and all that, and there's a consensus protocol, and then there's a virtual machine, and then there's a gas limit. All of that together induces this thing called a block, and a block has a certain amount of block space that Ethereum sells. And that's the Ethereum's business model, selling block space. The EigenLayer is basically just saying, hey, Ethereum doesn't only have the refined product, block space, to sell. It also has the raw material, decentralized trust, to sell naturally. What is this raw material? It is that the stakers and operators together are inducing a cross network that other people can now consume in ways you can't consume block space. You can't go and tell inside the block space how the nodes should come to consensus among each other. The consensus protocol is already fixed at the base layer. Suppose somebody has a new idea for how to distribute data across these various nodes, how to construct a peer-to-peer network across these various nodes. These are not expressible at the level of block space. So the programmability is bound by, I give you this particular dimension of decentralized trust. Instead, EigenLayer just basically goes all the way down and says, I give you raw access to decentralized trust. And the way we do it is, if stake is the source of decentralized trust, then if I can use the stake to not only make a promise that I'm going to run Ethereum correctly, but I'm also going to run ABCD other networks correctly, then you are able to transport the trust to these ABCD other networks. And so that is why we call it restaking, because using stake, you're making a promise, running one protocol. And what we're now able to do is to extend that. So restaking is a little bit of a meme. So the core concept, I would say, is generalized programmable staking. So when you're staking, you're promising that you'll run the Ethereum protocol correctly. And EigenLayer is saying that you can promise that you'll run this thing correctly, that thing correctly. So it's generalized. And what those things are is programmable, not by the staker alone, but by other people coming and saying, hey, if you opt into my network. So these other people, the people using the producers of decentralized trust, or stakers working together with operators. Why operators? Of course, just the same way that Ethereum has operators, because the person bringing the stake may not themselves have the qualification to run a node technically. So they delegate their stake for somebody to actually run the nodes for them. And EigenLayer delegation is non-custodial, which means when the stake is all remaining in the EigenLayer protocol, and you're just asking a service provider to run the services for you. So stakers and operators together manufacture decentralized trust. Now, who's consuming it? We call them, I think Ben already alluded to, AVS, actively validated services. You can think of these as, hey, I want to build a service on top of, the same trust network, whether it's an Oracle, whether it's a bridge, whether it's a data availability, whatever the system is, and then I just want to throw it on top of this, trust network. And so that's we call them AVSs. And the term AVS, actively validated service, is chosen to be different from, we're not calling it an actively validated chain. So we don't think of necessarily chains as the things that are built on top of EigenLayer. We think of services. And why do I say services? It's because the way you would construct an application, I think this reflects a certain vision for how we think, the space is going to evolve. And one particular way is that, people argue between whether it's going to be monolithic, which means there's a single chain on top of which like all the applications go, or modular, like, oh, I'll use the data availability here and a consensus there and a settlement there and so on. But our view is that it's going to evolve much more like the cloud, where you have a bunch of services. So infrastructure-oriented people create infrastructure services, like database as a service, AI inference as a service, homomorphic encryption as a service, encrypted computation as a service. All of these are services, and an application will concatenate these services and then say, I'm using this as an ordering service, I'm using encryption as a service, I'm using AI as a service, all of this together, and then build an application. So this is our vision of like how crypto application development will look in 5 years. And we are kind of building towards that vision, the idea that services come in and services work together to actually produce an induced application.
That's great. Thank you. And I wanna pull that thread a little bit more in a few slides. But so like I think taking a step back, so and correct me if I'm wrong, I'm sure I'm going to misspeak a few times, but the way, like from a broad kind of simple sense, in some senses, EigenLayer is a marketplace for decentralized trust, and it connects restakers, builders, and operators effectively. The other thing too, I think, again, for maybe like the 101 aspect of this for folks, again, that are just kind of getting involved, and in a practical sense of how you actually engage on EigenLayer, as far as I know, unless anything's changed, the ticket to entry is staked ETH. And there are two basic forms that can take. You can have a liquid staking token, you can deposit that on EigenLayer. And then there's what I would call the direct path. In other words, I have 32 ETH. I want to run a validator on Ethereum, but I also want to engage on EigenLayer. In other words, I want to open myself up to restaking, enter that marketplace. In that case, then the first step is creating an EigenPod on EigenLayer's website, activating a validator in whichever way you normally would. So, if you're a solo staker, you might use Ethereum staking launchpad. If you're a customer of a staking service provider like Figment, you might use our app, you might use our API. But however you activate a validator, you do that and you point your withdrawal credentials at the EigenPod, and that kind of represents most of what happens on the direct path. But there are these two paths, and what I've described so far is the first step of restaking. In other words, engaging on EigenLayer and effectively having EigenLayer recognize your staked ETH. The second step, which just launched, I think, about 2 weeks ago, or just a little over, is the second step, which is delegating to an operator. So I think, as we go through this, especially for folks that are just starting to look at this, just starting to learn and understand, it's important to keep those two steps in mind, and I'll have a little more to say on that in a minute. Next slide, please.
We have one question from Hadley Stern.
Okay.
Are there more risks to layer 2 staking than layer 1? And does Figment offer this?
To layer 2 staking than layer 1. Okay, so when I hear layer 2, I think of rollups and things like that. I'm not sure if the intention is things that are built on top of Ethereum. And I think in that case, a lot depends on, like, if you're looking at L2s just generally, I don't want to spend too much time here because I feel like it could be taken as a roll-up question, or anything, in fact, that's built on top of Ethereum. I think a lot depends on what's being built. So I think, we can get into this in a little bit, but I think when you look at AVSs, they really do run the gamut in terms of complexity. So you can have simple app chains on one side, and theoretically you could have full-blown protocols built on top. So I think when you think about risk, That's kind of the way to think about it. And you have to look at each AVS, you know, as if it's its own protocol, and do your diligence that way. In terms of Figment's offering, I won't say too much and speculate too much what we will be offering. Currently, we do have a public operator that's running EigenDA, the first actively validated service. But I think maybe I could talk more about that in a little bit, because I think we're kind of going downfield a little bit. So yeah, if I didn't answer the question, please ask it again and ask more specifically what specifically you want to know about the L2. Were there any other questions?
There is one more. When will AVS rewards be available?
Okay. You know what? I think I want to speak about rewards and penalties later, and so maybe we can address it in a few slides. So yeah, why is EigenLayer so important? So maybe if I could just quickly address from a staker's perspective why restaking and EigenLayer is so interesting, then I could hand it to you, Sreeram, for some of the bigger themes in the ecosystem. So, you know, I think one of the things we're not going to get away from is the fact that everyone's like, the question we just got, what's the level of rewards? How much can we expect? And I think, of course, that's important, and folks are interested. But I think just from a staker's perspective, there's a related nuance here about rewards. And I think big picture, it's about taking back agency. So if you've been following Ethereum for a little while, you may have heard things like MEV burn, minimum viable issuance. And the idea is that, you know, the core community of Ethereum, core community I define as Ethereum Foundation plus core devs, some have talked about the ability, and some will say the desire, to reduce rewards per validator. And I think with restaking, what you do is you kind of diversify that aspect, in the sense that when you opt into restaking and you delegate to an operator, you open yourself up to this marketplace to effectively sell your portion of decentralized trust. And you then have AVSs in an indirect way competing for the decentralized trust you bring to that marketplace. So what I'm trying to say is, when you opt into restaking through EigenLayer, you take back a little bit of agency. You kind of remove the I don't want to say threat, but remove the chance that this one group will make a decision to reduce rewards. You have a way to augment your rewards and to expose it to market forces. Now, staking rewards on Ethereum are exposed to market forces, but there is this potential to, you know, reduce rewards. Two more quick points before I hand it over to you, Sreeram. One of them is that, you know, I'm not saying that these things are overly likely. I don't know how likely MEV burn is, or minimum viable issuance. You know, I would say my guess is they're not overly likely. The probability isn't zero, though. The other thing is, too, I hope no one takes this as a criticism of the Ethereum core community. You know, I'm looking at this from a very narrow view of what's in the interest of stakers. Whereas, you know, Ethereum core community has to worry about everyone in the ecosystem. So builders, devs, users, stakers, everyone. So from a staker's perspective, I would just highlight the idea of taking back agency as a staker and participating in this marketplace with your share of decentralized trust. Sreeram, I don't know, in terms of bigger kind of themes and why restaking and EigenLayer are so important.
Yeah, I think that's a really great summary. Another way of thinking about it is, when you talk about agency, when you're normally running Ethereum protocol, you are focusing on three things narrowly. Number one is the asset to be staked has to be ETH. Number two, the node operator that you're running is a machine that is specifically customized to running the Ethereum software. And the third one is the software that you're running is, you know, the Ethereum core node. And what EigenLayer does is unbundle all of these things. You could potentially, you're staking ETH, but you could also potentially stake other tokens. Your machine may have specific requirements that are, you know, in the Ethereum case, were very specially designed for, you know, a laptop in Venezuela to be able to participate. But there may be other things you would want to participate, which are not like that. They need special considerations. So operators can be like, so the first side is stakers in our market. Like, so now you're staking not only ETH natively, but also ST-ETH or other, you know, LS-ETH or other derivatives. Second one is you are now the operator can use more computational power. Per unit of capital, you can use more computational power, because some applications need it, and you're able to mix and match these things in different ways. The third one is you're not just running the Ethereum node software, you're running arbitrary other node software, which is what we call AVSs. So EigenLayer is an unbundling of the staking stack so that you have freedom, degrees of freedom in actually optimizing each of these things separately.
That's great. Thank you. And then I think, we spoke a long time ago, and one of the concepts of Ethereum, comparing Ethereum to what the world was like before Ethereum, there was this big step up in terms of adding smart contract capability. And I feel like in some senses, EigenLayer and restaking is kind of a next step along this evolution in a way, in terms of being maximally flexible for builders. So I think that's another thing, another benefit for sure. Next slide, please. So that kind of takes care of like the 101, bringing folks up to speed. So I want to cover where we are today, or especially where we were, I guess, roughly 2 weeks ago. So, EigenLayer launched EigenDA, the first actively validated service. Also, delegations went live. So as I mentioned before, those 2 steps of restaking, the delegation piece went live. Also, 7 additional AVSs were launched and the LST caps were removed. So a lot of stuff going on, very exciting. And of course, congratulations, Sreeram, to you and your team. This is the nice culmination of all the work you folks have been doing. So I guess would love to get kind of some high level thoughts, if you have any just generally on the launch. But also just curious, when I'm thinking about all these AVSs launching, and this is more of kind of a practical question, I guess, but is the launch of AVS, is that permissionless? What are your thoughts on AVSs launching, and not so much the development part? I'll have another question potentially on that later, but just in terms of these 7 got to launch, what does that look like? Is it permissioned? Is that going to be the future?
Yeah, this is a great question. So in terms of what features exist on mainnet, 2 major things do not exist. There's a lot that exists, but there's 2 major things don't exist. The lot that exists is, there is stake. Stakers can delegate to operators. Operators can download and run, decide and opt in and run different AVSs. AVSs can be built, right? So there's AVS. Building an AVS requires building a contract and building, the software, node software for the AVS. And EigenDA is live, which means the first AVS which actually uses EigenLayer is live on mainnet. So we have a lot which is live, but some important things also missing on mainnet. And the 2 important things that are missing are payments and slashing. So right now, AVSs are not able to pay to the operators because the payment functionality is missing. And the payments and then slashing, which is, or if you misbehave on these different services, then you'll be able to slash. Like these 2 are missing. Slashing, obviously, we're taking a careful approach. It's user stake, so you don't want to turn on slashing abruptly. The slashing functionality was already there on our mainnet from June last year. It is there in the core contracts. It's just turned off. And this is a very, very cautious approach. EigenLayer has been taking this from day one. The TVL races, everything, we just take a cautious approach because despite that there are always risks, but we want to go as carefully as possible. So slashing, that's the thing. Payments is coming up in the next 3 months. And the reason payments is not live is we want to see what market structures are ideal for actually enabling payments to the different sides of the market participants. And it also answers one of the questions. So it's coming up in the next 3 months. We are understanding what is the real, right now, like when I launch an AVS, some operators are opting in, to support these AVSs as early supporters. But over time, of course, the marketplace has to be totally in protocol, and that's where we are headed. But those are the 2 features: payments and slashing are missing on mainnet. So to be fully transparent. So and that's the roadmap is in 3 months, we'll have payments, and a few months down, we'll have slashing. But just cautiously, we are moving through each of these steps. Okay, so what do these AVSs do? What does EigenDA do? EigenDA, we haven't talked about, so I'll spend like 30 seconds explaining it. EigenDA is a data availability system for Ethereum, which means, Ethereum has this big scaling roadmap, the modular roadmap, where all the work moves on to these rollups. But rollups still have to publish data to Ethereum, and publishing data to Ethereum is very expensive. Recent upgrades have made it somewhat cheaper, but the Ethereum pricing model is based on contention, which means if more demand is there than supply, then the price starts exploding. It explodes exponentially. And so, but the total amount, and so it's basically demand versus supply economics. And the supply of Ethereum data, the ability to write data is very limited, like 32 kilobytes per second. And first time when I actually calculated this number, I just had to recheck it like 5-10 times. Am I missing some zeros or what? But it is 32 kilobytes per second. And of course, the reason is that it's like, you're having these, 800,000 validators, they have to come to consensus, there's all of them are replicating the data. EigenDA is a new innovation. And I mentioned earlier that, one of the reasons we started EigenLayer is that we had protocols we wanted to build that we could not build. And EigenDA is the first protocol like that, which is a scaling layer for data availability. And, there are various ways to scale. One of them we call vertical scaling, which means get more and more powerful machines, scale the network based on that. And Solana takes that approach. EigenLayer, since it's built on Ethereum and EigenDA, it takes the approach of horizontal scaling, which means you're not scaling based on nodes being more powerful. We're scaling based on there are a lot of nodes, and somehow we have to distribute the work across all these nodes. The reason it's tricky is when it is not redundant, when it's not fully redundant, you don't get the full security, because when everybody's repeating the work, then you get the full security. But only few nodes are like storing a portion of the data, then those nodes can be attacked and the network can be taken down. And so EigenDA is a mechanism, it's just a realization of the Ethereum roadmap. The long-term roadmap is called dank sharding. The update that went live recently is called proto dank sharding. It's an early version, also because Proto Lambda was a contributor to it. But that we just take that roadmap and then just bring it to the present. So that's what EigenDA is. EigenDA is, just to give a sense of what I mean by horizontal scaling, the system runs at 10 megabytes per second. So it's not 32 kilobytes per second, 10 megabytes per second. But each node, the node requirement to participate in EigenDA as a minimum participant is only 0.5 megabytes per second. So no node touches all the data, but it is secure as though you can attack the network only if a majority are malicious. So it is a really powerful combination. So again, coming from the Ethereum roadmap, but because it's out of protocol, we can do experiments and move fast and build various things and use funding from the free market, all of these things. This is one of the, unleashing permissionless innovation to accelerate Ethereum is kind of the EigenLayer vision. And EigenDA is a first example. Take the Ethereum roadmap, absolutely brilliant ideas. What do we not have to wait for 5 years for? And that's what EigenLayer is and EigenDA is. So that's an example, but there are lots of others, and yeah.
And just double down on that. Like, to me, it's, I mean, I don't have a really super specific idea about when dank sharding might show up, but to me, the fact that, in my mind, you could argue that EigenDA is superior to what would, or I shouldn't say would, but who knows if it'll be of much interest to the core team now that EigenDA is here. But that is pretty amazing. Like, I would think at least a few years away. And now we'll see what happens. Maybe it'll be de-emphasized because there is this.
Just as a footnote, the in protocol, things are always more secure than anything out of protocol. So whenever dank sharding comes, even now, that this is what we say to all our customers: if you were, use Ethereum DA to the extent that your cost versus security affords for it, to the extent that it is not. And if Ethereum's throughput is 32 kilobytes per second and your rollup wants to run like Solana, it's simply not possible. Whereas with EigenDA, it just opens up things that are simply not possible. And our own EigenDA's roadmap is, in 1 year, we want to be at 100 megabytes per second. In 2 years, it's 1 gigabytes per second. So we have like a very aggressive roadmap. And, hopefully dank sharding comes and it gives us all more highly secure throughput, because when it's integrated with the protocol, you get a lot of features like, if something bad happens, the protocol will fork around it, social forking, all these powers that only go for in protocol doesn't come, for Sreeram or EigenLayer or somebody else. And so that is absolutely the most secure block space that you could get. But because EigenLayer is Ethereum adjacent in a very fundamental way, it's the same stake, it's same node operators, you do get, a portion of that security, a portion for like running DA out of protocol. And our vision is when downsharding comes up, it'll serve a portion of the data bandwidth, but then you'll have this infinite scale. Our idea is there should not be a necessity for people to build here and there and everywhere. Let's just all build together on a common framework and system. Ethereum's here, let's get convergent evolution. Let's just get everybody building on top of this. So each one specializes in what they're building, and together it's more than the sum of the parts.
Very exciting. Very exciting. Love it. Next slide, please. So again, looking maybe where we are today and going back just a little bit in terms of adoption, the kind of high level point here is that 15% of stake is engaged on EigenLayer, which to me is crazy. That's fantastic. Just for folks, there are two charts here on the slide. The top one has just liquid staking tokens, and you can see what's happened over time. And you kind of see a bit of a step function. I kind of mentioned this previously, but up until roughly 2 weeks ago, LSTs were capped. And I think, Sreeram, that was just abundance of caution kind of thing, just taking things slowly. Okay. So you can see the effect, and you can see as things start to increase again as the cap was lifted. The bottom right is just a pie chart of all the ETH that's been engaged. And this is a few days old, so I think we're getting much closer to 5 million now. I think we're almost there. And then by the way, the bottom chart captures everything. You can see the purple band. That's the kind of the direct path that I talked about. And by the way, both of these charts represent the first step, that is engaging on EigenLayer and what we've seen. So, I look at these and I think it's pretty amazing just how quickly, when you think about it, in under a year, EigenLayer has 15% of all stake, which is more than half of Lido. I think that's fantastic. It's really something. So I guess initial questions from here, and I know you don't have a crystal ball, but just thinking about this kind of participation, where does it stop? And another thing too, just as an aside, I mean, obviously there are some folks that are kind of churning a little bit. So, on the LST side, some folks may have taken their tokens out of wherever they were holding them before and deposited them on EigenLayer. But from your perspective, I mean, I'm not sure if you know this, but how much of this is net new stake? And then also just in terms of the participation, what do you make of all this? And it won't ask you to predict where this is going, but just any kind of high level thoughts on this participation.
Yeah, it has been really surprising the amount of interest people have shown in participating in this ecosystem, and we're very delighted about it. Just one comment on the purple band here, which is native restaking. A lot of it is going through liquid restaking protocols. So these protocols basically, abstract some of the complexity of, hey, I have to stake, and then I have to delegate. I have to pick services when I'm delegating. So it's more work, and I have to figure out how to do this native restaking. And so some of the a lot of the purple one is liquid restaking protocols, which basically come in and say, hey, just put your ETH here, we'll do all this work for you, and then do risk management, all of these things. So that's a lot of the purple band. The liquid restaking systems have a little bit of introduced new risks and complexity as well, while minimizing user complexity, it increases underlying risks somewhat. So it is a trade-off between these two things, and different users have to think about which side they lean on and which systems they trust. So a growth of that segment has been interesting to see, that there is a lot of new stake going into that. I don't have the stats here, but a a lot of the new stake coming up is going to some of these protocols and getting natively restaked on EigenLayer. We had a chart like this, but maybe not in the slide. The other comment on stake is it's good to see a diversity of different modalities that people are engaging in rather than there's only one mechanism. And to give a little bit of sense for how we think about things, a lot of people expected we will create our own LST to compete with Lido and other systems. And we don't take that view. We take the view that there are the protocols which are neutral and objective cultivate larger ecosystems than oh, I have my own protocol and we have our own LST, which means now you're making subjective opinions that these are the right operators and this is the right incentive mechanism, all of these things. And our view is our aesthetic is very similar to Ethereum itself, which is that it's an objective, clear, transparent layer on top of which many different participants can come in and participate. And we're also seeing native restaking from institutions, like where you come in and you stake and you can control the operator. Hey, it's Figment, I like them, I'm going to stake with them, they're going to do all this work for me, and I don't have to go and trust these 50 or 100 parties which I don't know about. So it allows this expressivity, and different participants, different things are more appropriate.
That makes sense. Yeah, that's great. Next slide, please. So last slide, we were kind of seeing, that first step, engaging on EigenLayer. The second step, obviously, as I mentioned, launched a little over 2 weeks ago, is the delegation piece. So the top chart was actually provided by you folks. I think it was Sue at EigenLayer. So thank you, Sue. And this is kind of what we've seen in terms of the delegation. Roughly half so far has been delegated. And the bottom chart was taken from another source. It has to do with operators. So obviously this has been delegated. And to your point, Sreeram, a lot of these are LRT. So it does feel like it's this kind of liquidly staking token. It's the delegation piece seems to be driven so far by LRTs. But obviously, it's only been 2 weeks, and so I would presume that we'll see a lot more participation soon. Next slide, please.
So I see a question in the thing on. Okay. I just want to address that, because the question is about how to split between native restaking to minimize risks. As I mentioned, our roadmap right now doesn't have the slashing is not live on mainnet. So right now there is very little risk to restaking other than the contract risk, right? So you are depositing using some other system of contracts. There could be bugs. Try to test it as much as possible, but all of blockchain systems have risks. So that's the risk that one has to take to actually restake. It's not the AVS risk, it's because slashing is not live. And when slashing does go live, one has to opt in to what systems they're willing to take that slashing risk. And of course, that's what a lot of the payments would go to that. So in terms of actual risks today, it's just smart contract risk on EigenLayer, no flashing risk from any of the AVSs. In terms of why should stakers restake now versus a few months later, each of these AVSs have their own incentives and rewards, which some of which may be articulated, some of which may not be articulated, where they may reward early participants who bootstrap their network when they actually go live. They may have loyalty and rewards programs, all of this stuff, which are specific to each of these AVSs, not through EigenLayer. So that's one of the
sorry, great. So I think we've talked about this a little bit, rewards and penalties. You mentioned, likely in the next 3 months, give or take, we'll know more about rewards, and then penalties maybe shortly after that. And I think too, I would make one distinction here in the sense of when we talk about EigenLayer, we're talking, in my mind at least, we're talking about the marketplace. So when we talk about rewards and penalties on EigenLayer, I think of more kind of the plumbing of how things are going to work. When we want to talk about levels, then we're getting to what you just mentioned, Sreeram, which is each AVS in particular has its own decisions about, reward level, what its budget is going to be, how much it'll pay out, and things like that. So kind of two distinct things just to kind of keep separate for folks. I think, when we're talking to you, Sreeram, we're thinking kind of the high level and the plumbing. And that's what I take when you were talking about, rewards in the next 3 months. We'll know more about the flow and what that's going to look like. And that's kind of, but we're not really talking about levels right now. That's more of an AVS specific thing. I guess one thing just, and I know that, we'll know more about penalties, in the next several months, but if you wouldn't mind just for a minute talking about attributable security. So the idea, if someone, if I'm a restaker, I'm delegated to an operator and the operator breaks some rules of a particular AVS, when that ETH is taken away, what happens to it? And so I kind of want to tease out attributable security.
Yeah, absolutely. So this relates to both payments and so this payments and slashing are like a close dance of between these two systems, because now that's the give and the take, right? The give is that like they're giving payments, and why they're giving it? Because they're getting security. And what does it mean by they're getting security is that, if something goes wrong, I have concrete damages that can be induced onto the people creating the problem. So zooming out, the so that's the high level, that payments and slashing are a close dance. There is a tragedy of commons in pooled or shared security. And the problem is the following. Problem is that imagine there's a lot of stake on EigenLayer and they stake into already like many AVSs. The new AVS, let's say right now it's $15 billion. So $15 billion, let's say all of them restake in, let's say 5 AVSs. The 6th AVS comes and they can say, yeah, anyway, they're restaking into 5. They'll also restake into my 6th one. And so I don't need to pay that much. I need to pay a little bit so that, they'll actually like opt in and run it. I don't need to pay that much. And so this is a problem. And I think some people have noticed this. And of course, we've noticed this long back. And part of the solution to it is that basically this is a commons, that pooled security is a common value. Like, all of us are getting 15 billion. And so nobody is incentivized to grow the commons, right? Because why would you, hey, that guy's paying, I don't need to pay, right? Like this is a problem. So on the other side, the services, so this is the problem to the stakers. The problem to the stakers is that they're not going to be driven enough fee revenue to sustain the pool, and the pool might shrink if you have a system that doesn't understand how to do payments correctly. On the other side, what is the AVS getting, right? So if the AVS, all they're getting is this commons that, hey, there's $15 billion, and if something goes wrong, it can be slashed, but nothing is attributable back to me, then why am I paying more fee to the commons? Because if somebody attacks, if they're restaked across 6 services, likely they're going to attack all of these services. So, I don't get anything for paying more to grow the commons. Okay. How do we solve it? It's called attributable security. And attributable security says a portion of the stake is burnt, but a portion is redistributed to different players. And if I can guarantee to the AVS that if something goes wrong, you will be able to slash from the stakers and redistribute it back to your users. Imagine a bridge, and this bridge is transporting $100 million weekly volume. And it takes attributable security of 100 million. Now what happens is that they can tell their users, hey, I have ensured that operator misbehavior on EigenLayer is completely covered. Like, you're not taking that risk. If they give you a wrong answer, they'll be slashed, we'll get 100 million. Because now the get is going back to the AVS. The AVS is incentivized to pay for it. This is how we avoid market collapse, the tragedy of commons. And there's just a lot of details on this and like a facing of the roadmap, like everything else we've done. And so that's more details on this are coming up. But the attributable security should not be viewed as just a feature for the AVS. It is a massive feature for the stakers, because that's how people are going to pay. Otherwise, people are not going to pay. The AVSs are going to free ride on a commons. For everybody, 15 billion sounds like a big number. But the accounting that, oh, this guy is using 3.1 billion because base comes in and they build something on top. And they say, oh, now they're using 3 billion or 2 billion, or Arbitrum's now running this on top and is moving like, $500 million volume. Like, those are the scenarios where they will pay for it. And because they're paying for it, the stake grows.
Okay, that's interesting. Okay, so attributable security is the solution to this problem effectively. Okay, that's great. Okay, so thanks, Alyssa. 10 minutes. And apologies, this next question, system parameter changes. This is meant to just capture any big changes we can expect. Obviously, rewards and penalties will be the big one. Again, the kind of plumbing with EigenLayer, and then each AVS will make its own, announcement around that. But are there any kind of other big changes? And maybe a related question here. Do you anticipate there being any limit to the number of AVSs that an operator can run?
This is going to be operator determined. So this thing that I was talking about, attributable security, is not there are various ways to think about it. One way is you can segregate the security and say, oh, these stakers are staking into that AVS, that staker is staking into that AVS, that staker is staking. That kind of attribution is not very good for us. And the reason is, if that's the attribution, then you might as well have separate staking systems for each of them. Why do you have a joint staking system for all of them? The benefit with the way that we are doing attributable security is that even if everybody restakes into everything, there is still a portion of attribution that you can get. And this is managed by the protocol rather than by each staker trying to say, oh, I'm only operating this services. So that's the first thing. In terms of operators' limits, one of the things that we are thinking about is, in the world that we are in, there are going to be two kinds of operators. One is like a home operator who would be capacity constrained. And the other one would be like, either sophisticated operators like Figment or, people who are running on the cloud, right? Whether from home or anywhere else. And sophisticated operators in cloud can scale to like whatever is the thing that is actually rightly incentivized. So whereas home operators are going to have restricted capacity. So the way we see the market evolving is there will be services which need home operators because they need a lot of decentralization. Imagine I'm taking a secret and then splitting it into small chunks that are just distributed across the network. You wouldn't do it if I knew that there are only 3 major operators who had all the stake. Then basically, like, I'm just splitting among 3 nodes. And how much security does that give you? Whereas if I spread it among thousands of home nodes, that's actually measurable security. So where we see this evolving is because this is capacity constrained resource, the home operators. There are going to be some AVSs which will give a premium to home stakers for running these services which are relying extremely on decentralization. Okay. And there'll be services which are like run a lot of AI inference and promise with $1 billion that it's run correctly. And more centralized solutions are more appropriate. And this is one of the things that, going back to my starting point, which is EigenLayer being a marketplace for decentralized trust. So this is the first time we're selling this raw decentralized trust. Imagine the first time that somebody had to sell raw potatoes and create a commodities market for it. Now you have to grade potatoes along various dimensions and say, oh, this is, golden potatoes, and this is this, and this is like, you have to do a grading. Otherwise, you can't do like a commodities market for it. And so that is something that will emerge like, oh, these are the decentralized operators. Somebody will do that, and then they'll get a premium for decentralization, but they can't run a lot of services. So they'll be capped by what set of services actually can go on that lane. There'll be more centralized services, but they actually have massive computational capacity, and that'll scale and stretch with your demand, have high SLAs, guaranteed access, all of these things. And that people will be willing to pay for because it is premium in a different dimension. And so we see this segmentation over time will happen, and things that are driven more by economic stake and flashability will go on the professionalized segment, and things which require a huge amount of decentralization will go on the decentralization segment. So that's how we envision it. Our role is to build expressive markets where these things can be actually expressed, and the market can equilibrate carefully into those dimensions.
That's great. I love that. A spectrum. So a spectrum of demand for different types of operators. That's great. Last slide, please. So I don't know that we have time to cover all these, but I really want to dig in on the first two. I know we're getting close to time here, but this tweet, and I truncated it, so I highly recommend folks go check this out because there were more points you had in this tweet. But permissionless staking assets, this is really interesting to me, and I kind of feel like now, if you're not thinking so much about LSTs or ETH, and we're kind of moving away, this is in a sense moving beyond restaking, which I think is very exciting. So maybe if you could just spend a couple of minutes and just talking about, from your perspective, your thoughts on permissionless staking assets.
Yeah. The idea is, so the way this evolved is, first time when I pitched this idea of, hey, you can build services on top of EigenLayer, people were like, hey, are you crazy? I have my own token to be staked. Like, why would I use some other stake? And so this was a binary choice. The binary choice is, do I stake my asset or do I stake ETH? And this is a really bad position to put a developer in, because, stake my own asset, create utility and like engagement from the community. On the other side, stake ETH, get more security, which is not even available in your own native token, and get access to credible neutrality, that the service is not run by like my insiders and so on. It's run by this permissionless, open, neutral market. So this was a bad trade-off that we realized very early on in the design. So we said, oh, we need to allow custom staking or dual staking. So when you stake ETH, in parallel to it, you should be able to stake your own token, because your own token is your own. And this percolates into our thinking very deeply. Not only EigenLayer is built like this, EigenDA, which is a service, is also built like this. Imagine a roll-up using EigenDA can come in and say, I not only want my like data availability to be secured by this common layer, which is ETH staked, but also by my own roll-up token stakers. It gives a utility for their token, allows controls. For example, they can upgrade node software on their own community much faster than they can get a neutral operator set on EigenLayer to upgrade their node software. And if something was going wrong and they want to block all data availability things for their rollup till something happens, they can do it. And there's just a lot of really interesting dynamics that show up when you allow dual staking. But EigenDA is built like that, with custom staking add on top of ETH staking. And so EigenLayer itself was designed to be like, you could stake any ERC20 token. We don't open this up right now because we want to cultivate a quorum around ETH, because that's the biggest and most important staking asset. And this question here, which Ben has brought in, is when any asset can be staked, what asset will be staked? And the original AVS or staking, native staking along with ETH staking along with AVS token staking was an answer that one is the neutrality quorum, and the other one is the alignment, my own community quorum. And there is another answer to what should be the neutral quorum. Should the neutral quorum be ETH, or should it be USD or some other thing? And normally people think of this in terms of volatility, and opportunity costs. I think those are important dimensions. But I think on volatility, it is not the volatility of the asset relative to how much it costs to buy bread that matters. It's the volatility of the asset relative to the risks. Like, what if I'm moving $100 million, then maybe dollars is the right value. If I'm moving 100,000 ETH, then maybe ETH is the right asset, because cross volatility means I need more security per unit of actual value. So as ETH becomes monetarily dominant, which means things, the digital asset economy is denominated, like an NFT is denominated in ETH, bridges are moving around ETH and so on. The network effect is that the more monetary premium that ETH accrues, the more ETH staking is necessary to support it, to move all this value around and secure it. So that's an equilibrium. It is also possible there are USD denominated assets and you get USD staking that goes along with it. It's also possible, and with the things going on in Bitcoin, that maybe Bitcoin becomes like, accrues monetary premium and comes into Ethereum, and like BTC is moving around and BTC is staked. So all these are possibilities, but our core bet is that it's the ETH, the asset, is the one that's going to win because it has this economy already where things are denominated in ETH. L2s are, people think, oh, L2s is a problem for Ethereum not having value accrual, but the fact that the ETH, the asset, is basically sitting in all these different L2s and being moved around, and the denomination of risk means bridges will absolutely be secured by restaked ETH. There is no question, because that's the right, like, it matches correctly. So that's our thesis.
Okay, that's great. But I mean, obviously, this permissionless staking assets, not this year. That's in the future. That's to come.
It's coming up. It's in the future. Yeah.
Okay,
So
that's very exciting.
We want to get our, yeah.
That's great. That's great. I know we're at time here. I don't know if there are any last questions, Alyssa.
There are these two questions here that
okay.
I can just maybe briefly answer. The one on like partial withdrawals, right now, if you're a native restaker, claiming your rewards, which are called partial withdrawal Ethereum rewards, requires doing some proofs on EigenLayer, which are somewhat expensive. We have an aggregation mechanism coming up, also at least 4 months out, so which will massively reduce the amount of costs required to claim your rewards on Ethereum. The next one is any plan to allow redeemable rewards to be restaked by LSTs. Yeah, this is also an interesting thing, but I don't think we will do this ourselves. There will be other services. Basically, the question is, can I take the rewards that come out and then stake them back into EigenLayer? And this is going to be a more complex question, because rewards in EigenLayer are not necessarily all in ETH. They may be in other denominations. And so we see things like liquid restaking protocols will be doing some kind of like rebalancing and then staking some of it back. There may be other third-party services also which do these things, but not planned in protocol.
That's great. That's great. So that looks like that's it. So Sreeram, thank you so much for joining. I know you're super busy. Congratulations to you and your team. Very, very exciting. This is great. Thank you for joining. I don't know if you had any parting thoughts on EigenLayer or otherwise, but thank you.
No, Figment has been a great partner and supporter for us from the beginning, and looking forward to working together with you and the Figment community.
Thank you. Absolutely. And thanks to the rest of you folks for joining. Hopefully this was educational. It was certainly for me. And yeah, again, really enjoyed my time with you, Sreeram. Thank you.
Thank you so much, Ben. Really appreciate it. Thanks also to the audience for all the great questions. Take care.
Thanks, folks.